With this video, I'm going to be covering two things. Number one, I'm going to be reviewing some good components of a good procedure versus a bad procedure. And I am also going to be covering what my expectations as a teacher are when I go through and I grade your project, what I'm actually going to be looking for. Okay? So, first thing, what really makes up a good procedure? Well, the first thing I want to tell you is if you look right down here, I have uploaded a PowerPoint that I usually would go through students with, covering some very specific examples. And I'm just going to highlight a few of the steps. I believe in the PowerPoint there are 7 different steps, but I want to highlight a couple of them, okay? Because I think that some of them might apply to you. All right. The first one is that you want to make sure, and this is clear cut, there should be nobody in the 8th grade that does not do this. Okay? That when you write a procedure, it needs to be in numbered steps. Okay? Numbered steps. Step 1. Step 2. Okay? And each of those steps should be in a sentence. Okay? A clear, direct command sentence. Okay? When you think about a procedure, you want to imagine that you could give this procedure to somebody else and they would be able to do it if you were not in the room, if you were not in the state, or if you were not even in the same country, as long as they all spoke English. Okay? And if you don't make it very clear exactly what needs to happen in each step in order, okay, it's not going to be repeated in the same way. That's why scientists write procedures. They write procedures so that other people can repeat their experiments and see if they're any good. See if they get the same results that the scientists did that first performed the experiment to help validate results. Scientists are all about testing, retesting, and validating to make sure that these conclusions are still accurate and true. Okay? So, numbered steps. That's the first one. If you just write things in a paragraph, you're going to get things that are lost in the mix. Okay? Step 1, numbered steps. Literally, step 1, numbered steps. In a clear command. You don't want to get too wordy with it. Yes, you want to be detailed oriented, but you don't want to be so detailed oriented that you can't actually figure out what you're asking people to do in the step. Okay? For example, and this is something that I believe was said in the PowerPoint. Okay? Step 1, get 50 milliliters of distilled water. That is a perfect, clear, concise step. I know exactly what I need to do. Kind of. This would probably be a little bit better. Get 50 milliliters of distilled water, or measure 50 milliliters of distilled water in a beaker. That would be a good step. Okay? See how I changed that? How I tweaked it? How I added a little bit to it? Because if I just say get 50 milliliters, how are they going to measure that out? You actually have to measure it in that process. Okay? So, make sure that you're specific, but don't be too wordy. Okay? Don't say measure 50 milliliters of distilled Hy-Vee brand water in a 2-inch tall beaker. Okay? We don't need to know that. As long as the beaker has 50 milliliters measured on it, you're going to be okay. Make sense? So be specific, be precise, and tell people what you want them to do in that step, but don't give them too much. Okay? Here's the other thing with procedures and steps. Okay? You can write it, you could actually do your experiment, and you could revise your procedure to make it even more specific, because sometimes trial and error is involved with science. You might think that this is going to work the way that you have it planned, but it might not. And that's okay. All right? Sometimes there's failure in science, and that's okay. So we look at a failure, and we see how we can try to make it work for us. Okay? So if it doesn't work the first time, you can go ahead and revise your procedure. Make it accurate as to what you actually do. All right? The last thing that I want to point out to you as part of the 8th grade procedure writing is the idea that every 8th grade procedure needs to have an accompanying diagram with it. A diagram is just a labeled sketch that shows what your setup is to help people who are visual learners, okay, see what's going on. Okay? Do you have to diagram out everything? No. But you should have a general diagram showing your completed lab setup. Okay? You can create it on the computer, you could sketch it out, either way, as long as it's labeled and it shows what's happening in your procedure. Make sense? Excellent. All right, the second thing and last thing that I wanted to talk to you about is what my expectations are for your project. And I'm just kind of pulling up my rubric here. And for your procedure, okay, these are the things that I'm looking for. And some of these things I've already talked about. Number 1, it's in numbered steps. Okay. Number 2, that each step is complete and there's no steps that are missing. Okay. And number 3, that you have a diagram of your setup. Okay. Those are the 3 things that I'm looking for in your procedure. Okay. Pretty simple and not too difficult to handle. You're going to be actually working on including your procedure in your research proposal to me. The research proposal is on this page, and you can start working on that at any time once you've decided on your science fair topic. Okay. Your procedure can be a work in progress, okay, but you want to have at least an outline started before you actually start your project. All right? I wish you guys the best of luck as we get started on this experience. Okay, of Science Fair together. It is truly a journey that each one of you are going to take. You're going to learn so much about yourself, and I'm going to learn a lot about you in the process as well. All right, good luck. I am here if you have questions or if you need help, or if you need materials or resources that I can help provide from the classroom. We'll see you guys later.